For this video, we are asked to identify how many surjective functions are there from set A with elements 1, 2, 3, and 4 to B with elements A and B. Take note, if we talk about surjective functions, we are determining the number of ways to distribute these 4 elements or 4 distinct objects in our A set A into, let's say these are boxes, box A and box B, considering that none of these boxes would be empty. In short, A and B will always be included in the mapping. We had the formula presented in the previous video. The number of surjective mappings, f of n and m, is equal to the summation of -1 raised to k, m combination k, m minus k raised to n, where k starts from 0 until m. Okay, so the thing here is we need to identify what is m and n, and later on expand this to get the result. So our n here is actually the cardinality of your set A, which actually has 4. Your m here is the cardinality of set B. We have 2 objects. Again, distributing these 4 objects into 2 boxes, providing, and these 2 boxes are actually distinct, okay, meaning they are different from one another. They look differently, and considering that none of the boxes will be empty. So by that, f of 4 and 2 is equal to the summation of -1 raised to k. Your m is 2 combination k. You have 2 minus k raised to 4 as your k starts from 0 to m. So let's try to expand this. The first one is -1 raised to 0. You have 2 combination 0, 2 minus 0 raised to the power of 4. Next, -1 raised to 1, 2 combination 1, 2 minus 1 raised to the power of 4. Next, plus -1 squared, 2 combination 2, then 2 minus 2 raised to 4. We end up here because we have, that's actually the value of our m until 2 alone. We simply try to solve this. Simplify. So that's 1, -1 raised to the power of 0. 2 combination 0 is also 1. This is actually 2 to the power of 4. Plus, that's -1. Then you have your 2 combination 1 is 2. Right, you can check that in your calculators. 2 combination 1 is 2. And then we have here 1 to the power of 4. Then plus, -1 squared is just 1. 2 combination 2 is also 1. Right? Again, check that in your calculators if you're confused. And this is 0 to the power of 4, which gives us this entire term to be equal to 0. Then, the next part here is to simplify that. That's actually 2 to the power of 4 is 16. You have your minus 2 because that's 2 times 1 and plus 0. So how many surjective mappings we can have for 4 distributed to 2 distinct objects, considering that those boxes will have an element. Okay, we have 14 of them. Now we can try listing all of this. If you would like to, let's try to illustrate the 14 items here. Take note that if we talk about surjective mappings, is let's say f of 1 could be A, f of 2 could be A, f of 3 could be A, and f of 4 could also be B. I chose B because if we're choosing, I'm listing here A. If I'm going to choose A, that means all of them are on box A, leaving box B empty. The point here is again no box should be empty. So let's return to B. That's the first surjective mapping. Now let's move B on upwards. So f of 1 is A, f of 2 is A, f of 3 is now B, f of 4 is A. Next, f of 1 could be A, f of 2 could be A, f of 3, sorry, we are moving B, so we have B, f of 3 is A, f of 4 is also A. So take note, we have 14 of them, so we still have 11 more. And to illustrate that, so we have here f of 1. Take note, I'm using the elements 1, 2, 3, 4, and A and B. So f of 1 could be placed to B, f of 2 could be placed in A, 3 could be placed in A, and 4 could be placed in box A. That's the first 4. Now, what if we'll start again? You have A here, A, and then you have B, and again B. And then we will be moving the third one. So you have f of 1 is A, f of 2 is B, f of 3 is A, f of 4 is still B. That's 6 already. F of 1 is B, f of 2 is A, f of 3 is A, f of 4 is B. Okay? So that's the next one. What if from this, we'll be moving, let's try to move first this B now upwards. Okay? So you will have here f of 1 is B, f of 2 is A, f of 3 is B, f of 4 is A as well. Now the next one is moving that there. That's already 1, 2, 3. That's 8 already. So f of 1 is B, f of 2 is B, f of 3 is A, f of 4 is also A. So that's 9. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. There's still 5 more. What would happen next here is, if we're going to make sure that these go together as we move them up, so you will have the next one, f of 1 is A, f of 2 is B, f of 3 is B, and f of 4 is A. Now, if we're going to move that here, that's just similar to this one here, so that's already 10. Okay. What if we will go now to having f of 1A, and then the rest would be B? Again, this is a guarantee, okay, that all or both boxes would be non-empty as we have A. We don't need B here because all of them will be on B and A leaving 0. And then instead of moving the 3 B's up, I'll be moving A down step by step. That's already 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Sorry, 11. That's 11 already. So you have f of 1 is B. F of 2 is A. F of 3 is B. F of 4 is B. Next, f of 1 is B. F of 2 is B. F of 3 is A. And f of 4 is another B. We still have one more. When we move that, exchange them. So you have f of 1 is B, f of 2 is B, didn't have much space. F of 3 is B, and then f of 4 is A. So you have 4, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 14. Yes, there are 14 surjective mappings for the given sets. We have A, 1, 2, 3, 4, and B, A, and B. Okay? So that's the illustration. At the same time, if you don't want listing, you could automatically attack this using the multiplication principle. Of course, there are, for each of the elements, 1 will get 2 mappings, 2 will get 2 mappings, 3 will get 2 mappings, and 4 will get 2 mappings. The 2 is A and B. That's actually 2 to the power of 4, which is 16. But why do we have 14 here? We actually removed 2. The 2 mentioned to be removed is when we only place everything into one box. The A, that's one box, and the other would be B, 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 and B. These are part of this count, but since we are talking about surjective mappings and that none of the box would be empty, here would leave B empty, this would leave A empty, so they are not counted. Hence, that's why we subtract by 2, so we still get 14. Okay? So, let's talk about another implication here. If, say, for example, the boxes here are identical. This is what will happen if the number of boxes are distinct, meaning there is clear distinction whether what is A and B, whether or not they are of different color, different sizes, different shapes. So they are distinct. But what if they are identical? That is, now we are going to move to another concept. Here, we talk about the Stirling number of the second kind. It will be presented in the next video. Thank you very much for watching.